Good morning, everybody. Am I audible? Am I audible?
Yes, ma'am, you are audible.
Nippani, am I audible?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes. Chikkodi also? Raibak?
Audible, miss?
Yes, I'm audible, right? Raibak students?
Yes, yes.
Yes. Okay, okay, okay. Thank you. Fine. Can you tell me what were we discussing in the previous session? Anybody from Nippani? Can you tell me? We were discussing about. Did we start with F block?
Yes, miss.
Yes, we have started with F block already, right? Or was I only discussing about D block elements?
Yes, preparation of KMNO4.
I was discussing about, yes, more about potassium permanganate and potassium dichromate. They structure their magnetic properties, right? Yes. So today we'll end up this chapter, D and F block elements. Okay. So today we'll discuss few questions about D block elements, and also we'll start with F block. And I have taken up those questions from F block which are very important. You know, in F block elements, the part, if you see the chapter D and F block elements, 90% of the chapter is about D block elements. Only remaining 10 part is about F block element. Okay. So in F block elements, I cannot say the question will not come. Question will come, but the questions are highly repetitive. The same kind of question you can expect in F block elements. Okay, they are not variety of question that you could see in F block elements. So today we are going to discuss those repetitive kind of F block elements question. Okay, before that we'll discuss few questions on D block, and let us start with the questions which you will be able to answer. Not this. This one. Yes. So those who have cue cards, you can answer using cue cards. I think Nippani students have cue card. You can answer using cue card. So here we have compounds, and here they have mentioned oxidation state, and you have to match those compounds with the respective oxidation state of the metals or
Option D.
the other element. Option
D.
D, fourth one. This is from which college?
Nippani.
Nippani. Hey, Nippani, yes, good you are answering orally, but along with that, I want everybody to answer using cue card also. I want everybody's answer. Yes, I need poll result.
Option
Nippani
C.
students, be quick. Option C.
Option
This
C.
is from Raibag, I guess. Yes,
Yes.
option C. Ha.
Option C.
Option C. Okay. I'm just waiting for the poll result. Very few of you have
Option C.
answered option C. Okay. Nippani, more answers needed. Everybody, especially class number 19. Are you answering everybody using cue cards? Yes, yes. Now I'm getting the poll result. Yes. Option C. Most of you are going with option C only. Okay, now let us see. I think this is visible on the board. Fine. So here we'll take -2 for ox. Is this visible, this color? Whatever I have written, is this visible?
No,
Pink
miss.
color?
No,
Yes,
miss.
ma'am.
No, not
Yes.
visible. Okay. For some it is not visible. Okay, I think yellow will be visible. Yes. For oxygen charges -2, right? 4 into -2, -8. You will take that to right hand side, you will get plus 8, right? So yes, yes is 2. We have, yes, sorry, yes is plus, this one. We have only one option where S is matched to plus 8, that is option A. I don't see option C is a correct answer. Option A could be the correct one. Let us calculate others also. So this is clearly plus 8. I mean, you should be remembering this also. Look, while discussing the common oxidation state of D block element, I told you among 3D series, manganese is the one which can have maximum number of oxidation state and maximum oxidation state, that is plus 7. It is also taken by manganese. But if they ask you as transition metal as whole or D block elements as whole, your answer should be osmium, because osmium can take up plus 8 oxidation state. I had mentioned that, and we can see such compound of osmium in this question, right? So here we can see it is plus 8. Okay, what about nitrogen? Plus 1 for hydrogen, minus 2 for oxygen. So it is, let us take X for nitrogen, plus 1 plus 3 into minus 2 for oxygen. So minus 6 plus 1 minus 5, and minus 5 if it goes to right hand side it becomes plus 5. So here nitrogen is in plus 5 oxidation state. R should be equated to 1. So we have that in option A. Yes. Next one, let us take this one. We don't know, we have to find out for chromium. 2x and 3 into minus 2 for oxygen. Equate this to 0. So this is 2x minus 6 equal to 0. X is equal to plus 3. So P should be plus 3, that is P should be related to 4. Now obviously Q has to be this one, 6. But how CrO5 is 6? If you directly use the same method wherein you give minus 2 for oxygen, what should be the oxidation state? Can you tell me? If I use minus 2 and calculate plus 10, plus 10, but we don't have plus 10 in the option also, and yes, plus 10 cannot be for chromium. How to find out oxidation state in such case? You might have studied this part in your first year, redox reaction. For some compound, you cannot directly use this one. For some compound, you should remember this structure. So this is one such compound wherein you have to remember this structure. This chromium pentoxide, the structure is like this. We call it as butterfly structure, like a butterfly. Okay, so this is the correct structure of chromium pentoxide. Now find out the oxidation state. How do we do that? Look, chromium is a metal and oxygen is a non-metal, and non-metal generally are more electronegative, right? So you try to give charge. Heg charge kodtira? Try to give charge as if you're breaking a bond. Okay, now let us assume I'm breaking this bond, chromium oxygen bond, chromium oxygen bond. You tell me which will get negative charge, oxygen or chromium? I'm gonna break chromium oxygen bond over here, this one and this one, everywhere. Okay, I'm gonna break this bond. Tell me which element will get negative charge? Oxygen or, yes, very good. Oxygen being more electronegative, it will get negative charge. Okay, this negative, this negative. Look, illi negative bantu andre illi en barutte, this will get positive. Again negative over here, positive over here. Negative over here, positive. Negative, positive. Already 4 positive done. Again break these two bonds. Negative, negative, positive, positive. Total how many positive this chromium has got? 6 positive. Okay, 1, 2, 3, 4, 5, 6. How do you get that positive charge? By thinking as if you're breaking a bond. Okay, then yak negative positive kodtidini andre, I am trying to understand where the electron density is. These are taking away the electron density, that's why it is getting negative charge. The electron density is decreasing in the chromium, that's why it is getting positive charge. Okay, this is how you say it is plus 6. plus 6. Remember, not all compound can be, you cannot find out oxidation state in this spaces. Remember this one exception. Okay, only this compound has exception in D block elements. Remember this exception. Chromium pentoxide plus 6 oxidation state. Okay, yes. Now, we'll go to next question. This one. Those who know, for whom this chapter has been completed, you may know this reason. I want answer from you people, for whom this chapter is completed already. For whom this is not completed, leave it. I'll explain. ಏನಾಗತ್ತೆ ಅಂತ. Cu2 halides, that means Cu2 plus, are known except iodide. That means CuI2 is not known. Why CuI2 is not known? I mean, even if you form copper iodide, it will decompose. Why so? And the reason is here. Can anybody tell me? Nippani, Chikkodi, nobody knows answer?
Option B, ma'am. Option B.
Option B. No, not exactly. Cu2 plus ion has smaller size? No. The reason is,
Option D.
look,
Option D.
option D, yes, very good. Option D is correct. Cu2 plus oxidizes iodide to iodine. You can see CuCl2, CuBr2, all those halide, but you cannot see CuI2. Why? Because in this CuI2, what happens? How do you break CuI2? It is Cu2 plus 2I minus. This is how this copper iodide is. Okay. Now, this iodide is getting oxidized. It has tendency to get oxidized. Who is going to oxidize this iodide? This copper 2 plus will oxidize iodide. Iodide ion will oxidize to iodine I2. Nodi, idu oxidize ಆಯಿತು ಅಂದರೆ copper 2 plus should get what? It should get reduced. It should get reduced to copper plus 1. Okay, this reaction everybody remember. This question is important. Okay, this is important. The reason kind of question, these are actually important in D and F block elements. Okay, copper 2 plus is oxidizing iodide to iodine. Look, iodine andre you have zero oxidation state. Okay, so it is going to oxidize iodide to iodine, and Cu2 plus itself it is going to get reduced. Okay, so this is the reason why CuI2 doesn't exist. This has more tendency to get oxidized. That's why it is happening like this. Fine. Okay. Now, yes. An explosion takes place. This is a new question. You might not see this particular question everywhere in your NCERT. You will not come across this kind of thing in NCERT. This is a new thing, one extra concept. I just want you to remember this. I told you this is fact-based lesson. So, an explosion takes place when H2SO4 reacts with KMNO4. So, why that happens? Because this will result in the formation of Mn2O7.
Option A, ma'am.
Yes, option A. Okay, option A. Please remember this one. Please remember this. When this happens, what is the compound that is being formed? Okay, Mn2O7. One extra added fact for you in the ocean of all the facts that is present in this D and F block element. Okay, Mn2O7. Yes. And one more important question. Yes. The product of oxidation of, this is important, students. This is important. This question is important. Those who know this one, you can answer. If you don't know, I'll tell you one important thing that you have to remember. Anybody from Raibag,
Option D.
UPU college?
Option D.
Option D. Very good. Option D is correct. Yes. Look, everybody, you have to remember this. What happens when you react iodide with MnO4 minus in acidic medium and in basic medium. Okay. Now, sorry. Yes. In basic medium, here they have given alkaline medium. Alkaline means basic medium. In basic medium, iodide will convert into iodate, IO3 minus. Okay, in basic medium. In acidic medium, it will convert into I2. So these two different species, it is getting converted. This is very important. I hope you remember I had given you one more important part in this KMnO4 oxidation. What does KMnO4 gets converted into in acidic, basic and neutral? That is also important. In some case it will convert into Mn2 plus. In some case it will convert into MnO4 2 minus. So that is also important. This is also similar to that. You remember this also. Okay. So fact based especially they'll try to question in this way only. Okay. Iodide to I2, iodide to iodate. This is in basic, that is in acidic. Direct question. Okay. No concept is involved in all these things. Fine. So one or two last question we shall discuss. Yep. So irregular trend in the standard reduction potential value of first row transition elements. So what do you mean by reduction potential? Reduction potential is value we get it from that electrochemical cell, all those things. But reduction potential means ability or tendency to get reduced. Tendency to get reduced in a solution. Okay, that is called reduction potential. So now this reduction potential value, it depends on three factors. Okay, one is sublimation. Sublimation enthalpy. Another is ionization enthalpy. Third one is hydration enthalpy. Okay.
Option B, ma'am.
Sublimation enthalpy means
Option B. B. Second one.
B. Yes, B. Right, it is very clear now. I want everybody to note down these 3 pointers. Reduction potential depends on these 3. Sublimation, ionization, hydration. Okay. What you have to do, first of all, you have to convert a solid into gaseous atom. Okay. Now, after converting that into gaseous atom, you have to ionize it. Converting solid to gaseous atom requires sublimation energy. Converting gaseous atom into gaseous ion, that means you have to remove electron. That means you require ionization energy. After the formation of ion, that ion should be stabilized in the water. That means hydration enthalpy. Water should get attracted towards the ion and it should release energy. That is what hydration energy. We have discussed about hydration energy earlier. So that's why these 3 factors are very, very important. This too is very, very important. First 2. Okay. So this is very, very important. Remember. So irregular trend, we don't see a regular decrease or regular increase in reduction potential. Actually speaking, we don't see anything regular in D block element. Everything is irregular. Whether it is ionic radii, whether it is ionization energy, everything is irregular. Melting point. So we don't actually say there is a regular trend. Why? Due to these things. Okay. So you have to remember these 3 pointers for that. One last question. Then we'll wind up D block and we'll start with F block. So this is based on the melting point. Melting point. Directly I have given you a graph, but we don't have those elements mentioned in the graph. Those who know this, they can answer, or else I can explain this. One thing which you have to remember. So melting point of this. Remember, melting point is generally based on more number of unpaired electron. If anybody knows,
Option B.
can you tell me? Option
B.
B? Yes, very good, very good. Option B is correct. Okay, remember here we have 3 graphs alva. Yenide ee graphs alli? This is atomic number versus melting point graph. 3 different graph eno. This graph we have plotted elements of 3D transition series. In this graph we have plotted elements of 4D. Okay, this is of 5D. So idರಲ್ಲಿ ನಿಮಗೆ ನೆನ್ಪಿಟ್ಕೋಬೇಕಾಗಿರೋದು ಒಂದೇ. You have to remember only one thing, that is peaks ಯಾರು ತಗೊಂತಾರೆ ಅಂತ. This peak. Okay, this peak is taken by chromium, molybdenum, tungsten. Okay, here you have at this low point manganese and technetium. So one thing you have to remember, as the transition series increases, that means if you go from 3D to 4D, 4D to 5D, the melting point keeps on increasing. The melting point keeps on increasing, and within a particular transition element, transition series, 3D chromium high, 4D molybdenum, and in 5D it is tungsten. Okay, ಇದು ಹೀಗೆ ಇದೆ. Chromium, molybdenum, tungsten, they all belong to a particular group, same group. Okay, these same group elements will be at a peak. So here we have chromium greater than manganese, chromium greater than manganese. That's why this option B is the correct order. So here I'm gonna finish D block part. We have discussed all kind of question from D block. Color, magnetic property, melting point, and the alloy property, interstitial compound property, right? The structures of different important D block elements and the exceptions in the D block elements. We have discussed all the kind of question probably that could be asked in KCET or NEET. I have discussed all those. Now we shall start with F block elements. F block elements. Now students, if you would find F block element is actually easy compared to D block elements, because you don't get different variety of question, only similar question. But you would find one thing difficult, that would be remembering this. Remembering what? Electronic configuration. Because in D block elements there is only 2 exceptions, that is chromium and copper. Apart from that, it has a regular trend in filling of orbitals. But if you take F block element, I have taken actinide series, there is no regular trend in filling of orbitals. You cannot say hige fill agatte hige. No, different ide. You have to remember. Odi practice ಮಾಡಿ ನೆನ್ಪಿಡ್ಕೋಬೇಕು. But remembering this is very important, because directly you will get question from the electronic configuration only. Mainly you will get question from the electronic configuration. So F block elements from actinium to lawrencium, the entire electronic configuration you have to study, everybody. And this also, lanthanides, lanthanum to lutetium, the entire electronic configuration. This is quite easy compared to actinides. Remembering lanthanides is quite easy. Okay, you have to remember the everything. And name also, lanthanum admele yaar bartare, all those things also you have to by heart. Keep periodic table in your room, go on by hearting these things again and again. Okay, that is the only way to remember all these things. So now, what do you mean by F block elements? Can you tell me what are F block elements? Or what is the difference between D and F block elements? Anybody?
Elements which receive last electron in anti-penultimate cell are called as F block elements.
Anti-penultimate F shell. The elements in which the electrons are going to anti-penultimate F shells are called as, yes, very good, F block elements. So now this F block elements, we have 2 F block category, that is lanthanides and actinides. I hope you know. Lanthanides have electrons filling in 4f orbital, actinides electrons filling in 5f orbital. Okay, so this thing you have to remember. And lanthanides, this part is also very important. To which period lanthanides and actinides belong to? Lanthanides belongs to 6th and actinides belongs to 7th period. Period means what? The rows. Okay, lanthanides belongs to 6th period, actinides belongs to 7th period. Okay, and they belongs to 3rd group. Group they won't ask generally, but they will ask you about the period. Remember this, which period it belongs to. Okay, so now we'll start with the question and then we'll try to understand the concept. Okay. I had asked you to bring textbook, right? Those who have textbook, you can refer your textbook or notes if you have notes. You have to tell me the
Option
correct
B.
configuration.
Option
Option
B.
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 Option B.
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 B. B. Okay. So they are asking gadolinium only, not the ion.
Option B, ma'am.
Direct
B.
B. Yes. 4F7, 5D1, 6S2. Okay. Let me show you whether it is correct or not. Yes. Yes. Here we have, right, gadolinium. Very good. 4F7, 5D1, 6S2. Okay, so correct. That is correct. Now, one more thing I wanted to discuss, because, yeah, we'll take this and discuss. Now, if you take 3D series or D block in common, you say the D block shows variable oxidation state, right? You have seen every D block element show variable oxidation state except zinc and scandium. But if you take lanthanides, not actinides, if you take lanthanide series, they show one common oxidation state, common, that is +3. That means in most of the compounds of lanthanides, it will be showing +3 oxidation state. This is very, very important point, generally asked question. Which is the common oxidation state? Remember, +3. Apart from +3, some elements will show +4 and some will show +2 occasionally. Which are those? Cerium, it will show +4. ಯಾಕೆ +4 ತೋರಿಸ್ತಾ ಇದೆ? ಎನಿಬಡಿ ಕ್ಯಾನ್ ಯು ಟೆಲ್ ಮಿ? +4 ಅಂದರೆ ಏನಾಗುತ್ತೆ? ಯು ವಿಲ್ ರಿಮೂವ್ 2, 3, 4. ಆಲ್ ದಿಸ್ 4 ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ತೆಗಿತೀರಾ. ಆಫ್ಟರ್ ರಿಮೂವಿಂಗ್ ಆಲ್ ದಿ 4 electron, cerium, how can that be stable?
It will acquire noble gas configuration.
Noble gas. Remember, ಇಲ್ಲಿ ಏನು electronic configuration in 3D ಅಲ್ಲಿ ನೀವೇನು ಬರೀತಿದ್ರಿ? argon 18, 3D5, 4s2, something like that you used to write alva. Illu aste you will write xenon 54. Xenon 54 ಆದಮೇಲೆ ಇದು ಬರುತ್ತೆ 54, 55, 56, 57, like this. Okay, now in cerium, if I remove 2, 3, 4, I end up getting +4 oxidation state. Okay, that's why cerium +4 is also stable. Next, ytterbium, if you take ytterbium, it can show +2 oxidation state. Is this yellow color visible on screen? Whatever I am writing on this, is it visible? Yes or no?
No.
Yes
No,
or
miss.
no? No, right? Okay, okay, fine. I will take this one. Because this is very important part, you should not miss this. Okay, cerium can show +4 and ytterbium can show +2. And terbium also can show +4. Remember, this can also show +4 and europium can show +2. Idistu point barbidi. Europium, cerium, terbium, ytterbium. Okay, apart from +3, remember all these elements can show +3. Along with that, cerium, terbium will show +4 and europium, ytterbium will show +2. So you remember this. Why europium shows +2? Can anybody tell me? Why +2 oxidation state also?
Completely
What
filled
happens?
filled orbital.
Yes, if I remove these 2 electrons, that means if it shows +2 oxidation state, it will get 4F7, more stable, half filled, right? So that's why these elements along with +3, they will show this also. Okay? Now, based on this, we shall solve one question. Where is that? Yes. So which one is incorrect? Which of the following is incorrect? You can answer using cue cards. Those who have cue cards, I guess Nippani students have cue cards. You can answer using cue cards. Incorrect statement.
D.
Option C.
Option C.
Option
C.
C.
Option C is incorrect. Okay.
D.
Option D.
D. D.
D.
C, D.
D.
Okay.
Option D.
Option D. Yes. Your poll result says it is option C. Most of you are going with option C.
D. D.
Okay.
D.
B, second one. Okay, option A, is it correct?
Option
The
C.
common oxidation state. Yeah, option C, option B ಸಿಗ್ತಾ ಇದೆ ನಂಗೆ ಜಾಸ್ತಿ. Let us discuss. Very important question. This is very, very important. ತುಂಬ ಸತಿ ಕೇಳ್ತಾರೆ ಇದು. ತುಂಬ common in all the competitive examination from lanthanides and actinides. This is common. Okay, so first C, the common oxidation state of cerium are 3 and 4. That is correct. Just now we discussed it can show 3 as well as it can show 4. So that means this is contradictory. Option C statement, right? The +4 oxidation state of cerium is not known in solution. Ill helta idive, it is known. Here it is saying it is not known. So this is the incorrect. This is incorrect statement. +4 and +3 both are known in solution. This is the incorrect statement. Okay, option C is the answer we got to know, but we have to understand what about the other option. What does this mean? Cerium +4 acts as an oxidizing agent. Students, always remember one thing. I told you cerium, terbium, ytterbium, they show other than +3. They show +4 or +2. But always remember, they will always have tendency to come back to +3. If I have cerium in +4, in a certain reaction, if there is a chance to convert into +3, it will convert. It is the natural tendency of all the lanthanide elements to be in +3. To be in +3. Now, in certain reaction, if cerium +4 is converting into cerium +3, what is happening? This is reduction or oxidation? You tell me.
Reduction.
Cerium is undergoing reduction, right? That means this is reduction process. Cerium is undergoing reduction. Undergoing reduction. If a particular element or species, if that is undergoing reduction, it will oxidize other. ತಾನು ರೆಡ್ಯೂಸ್ ಆದರೆ ಬೇರೆಯವ್ರನ್ನ ಏನು ಮಾಡುತ್ತೆ, ಆಕ್ಸಿಡೈಸ್ ಮಾಡುತ್ತೆ. ಸೊ if it is undergoing reduction, it will oxidize other. Always remember, it will oxidize other. If it is oxidizing other andre yav agent aaytu, it will be an oxidizing agent. Okay, any species of lanthanide, if you see them in +4 oxidation state, you remember they will act as an oxidizing agent. Now you tell me, if I take europium +2, ಇದೇನ್ ಆಗ್ಬೋದು? What kind of agent this can be? Europium +2.
Reducing agent.
Reducing agent, very good. Because europium 2+ also have tendency to convert into +3. To convert into +3. If it is converting into +3, this itself it is undergoing oxidation. It is undergoing 2+ to 3+ is oxidation. It is undergoing oxidation. If it is undergoing oxidation, it will reduce other. The one which reduces other is called as reducing agent. Yes. So remember, cerium oxidizing, europium reducing agent. These 2 points important. Remember, okay? This will act as a reducing agent. And +3 oxidation state of cerium is more stable than +4. Yes. Remember, more stable by means the tendency to be in this form is more. The natural tendency to be in this form is more. Okay? All the lanthanides will be having this natural tendency. That's why this is also correct. Okay. Now, I did not discuss this, I guess. Okay, this one. Sorry, I'm adding this in between F block, but this is the application of D block elements. You may not know everything, but you should be knowing at least two of the application without studying D and F block element chapter. At least two without studying D and F block element chapter. Let's see who will answer this. You can answer using cue card.
B.
So we know that D block elements are used as a catalyst, right? So this is used as catalyst in some of the reaction that has been given over here. You have to match that.
Option D.
Option
D. Number 4.
Option D, yes.
Option D.
Two of the reaction you should know. Option D, okay.
E.
No other answer apart from option D? Yes, poll result also you're saying option D. Okay, fine.
C.
I would start with this one. Why am I starting with this one? Because Cu2Cl2 you have seen in another chapter. Where is that? Can you tell me?
Haloalkanes and
Alkanes and
haloarenes.
Very good, yes. Haloalkanes, haloarenes. We have seen a reaction called Sand-Meyer reaction.
Meyer's
In that
reaction.
Sand-Meyer reaction, we use copper halide along with hydrogen halide, right? So this is Sand-Meyer reaction, Sand-Meyer. So B is 4 and this is B, right? Yes. B is 4 and we have B4 in only one option, that is D.
Option
Directly you can opt for D. But yes, we shall see that also others. Haber's process, do you remember? Haber's process is the production of ammonia. Okay, production of ammonia using nitrogen and hydrogen is called as Haber's process. In that we will use finely divided iron. And this is called Ziegler-Natta catalyst. Actually, there was another chapter called polymers. It is deleted for you now. So if you had studied the chapter, you would have found that this particular thing in polymer chapter. Okay. So Ziegler-Natta catalyst, this is used in polymerization of alkene. I take ethene and I carry out polymerization. Many ethene molecules I keep on adding. Those species will keep on adding and they will start giving polyethene cover. Okay, polyethene is made up of ethene molecules, many set of ethene molecules. To carry out that reaction, we need this catalyst, titanium chloride and trimethyl aluminum. Okay, and yes, V2O5 contact process, this vegetable oil. Okay, yes. Now, yes. Before answering this question, I would like to explain you one concept. Now there is one concept called, you don't answer this question now, I'll explain the concept, then we'll get back to these kind of question. There is one concept, let us take this slide only, called lanthanoid contraction. The same way you will have actinoid contraction also. Likewise, the contraction in lanthanide elements and the contraction in actinide elements respectively called as lanthanide and actinide contraction. What is contraction? What is contracting over here? The contraction in the size of the elements. Very simple. You go from lanthanum to lutetium or the last element. From left to right, you see there is a decrease in ionic radii. the radius of this lanthanide series or actinide series keeps on decreasing from left to right. That is called as lanthanoid contraction. Okay. Now, there are some consequences, there are some effects of this lanthanide contraction. What are the effects? Due to this lanthanide contraction, from lanthanum to lutetium, the basic nature, this is very, very important, students, the pointers which I'm going to tell you now. The basic nature decreases. Basic nature decreases from lanthanum to lutetium. Second is the 4D and 5D elements have similar size. Now, this two questions is very commonly asked. Yava 4D, 5D elements will have similar size. To answer this question, I am telling you, you have to remember the entire D block, not only 3D. You should remember 4D series, 5D series, zirconium, hafnium, everything. ಈ 3D ನಿಮಗೆ ಅವತ್ತು periodic table ತೋರಿಸಿದೆ ಅಲ್ಲ, 3D, 4D, 5D. ಯಾವ ಯಾವ ಎಲಿಮೆಂಟ್ಸ್ ಬರುತ್ತೆ, ಎವ್ರಿ ಎಲಿಮೆಂಟ್ ಯು ಶುಡ್ ರಿಮೆಂಬರ್. ಯಾರ ಕೆಳಗೆ ಯಾರು ಬರ್ತಾರೆ, ದಟ್ ಆಲ್ಸೋ ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್. ಓಕೆ, ಪ್ಲೀಸ್ ಟ್ರೈ ಟು remember this periodic table elements. That will help you to answer this. These are very fact based question. ಏನು ತಲೆನೇ ಅಪ್ಲೈ ಮಾಡಬೇಕಾಗಿಲ್ಲ. If you have good memory, if you are able to remember all these things, you can answer this question very quickly. Okay, any 3D, 4D and 5D elements ಏನಿದೆ, ಜನರಲಿ ಏನಾಗುತ್ತೆ, ಯು ಟೆಲ್ ಮಿ, ಐ ಹ್ಯಾವ್ 3D ಎಲಿಮೆಂಟ್, ಐ ಹ್ಯಾವ್ 4D ಎಲಿಮೆಂಟ್, ಐ ಹ್ಯಾವ್ 5D ಎಲಿಮೆಂಟ್, ಒನ್ ಬಿಲೋ ದಿ ಅದರ್. ದಟ್ ಮೀನ್ಸ್ ಐ ಆಮ್ ಮೂವಿಂಗ್ ಡೌನ್ ದಿ ಗ್ರೂಪ್. ಜನರಲಿ ಏನಾಗಬೇಕು, ಡೌನ್ ದಿ ಗ್ರೂಪ್ ಇನ್ ಜನರಲ್, ಯು ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ಪೀರಿಯೋಡಿಸಿಟಿ ಇನ್ ಫಸ್ಟ್ ಇಯರ್, ಡೌನ್ ದಿ ಗ್ರೂಪ್ ಇನ್ ಜನರಲ್, ಅಯೋನಿಕ್ ರೇಡಿಯೈ, ಡಸ್ ಇಟ್ ಇನ್ಕ್ರೀಸ್ ಆರ್ ಡಿಕ್ರೀಸ್ ಇನ್ ಜನರಲ್?
Increase.
Increase.
Increase, right? In general, order should be this. ಅಲ್ವಾ, ಈ ರೀತಿ ಇರಬೇಕಿತ್ತು. 3D ಕಡಿಮೆ, 4D, then 5D should be very high. But 3D is less, correct. But 4D, 5D almost have equal radii. Almost have equal radii. This is the effect of lanthanide contraction, remember. Okay, 3D and 5D series almost have equal radii. Remember that. And basic nature of lanthanides decreases across the period from lanthanide to lutetium. Now, I'll explain you why, but before that, I want you to answer this. I don't think so. This is yes. I'll explain you the phenomena, but before going to that question, we shall discuss this question. Can you answer this? Basic nature decreases from lanthanum to lutetium. Not
D.
correct is the question.
D.
D, yes, others, this one, poll result I need. Everything is fact based, you can answer.
Option A.
Option A. Incorrect. Huh?
Option C, ma'am.
Option C. A, C, D. Many answers.
Option C.
B. Okay.
Option A.
A. So it is between A and D. Most of you are going with, oh, A and D equal.
Option A, ma'am. Option A.
Option A. Look, just now I told you, you go from lanthanum, cerium to lutetium. You're moving from left to right. Okay? From left to right, what did I say? basic nature decreases. Basic nature decreases. Now, lanthanum hydroxide is less basic than lutetium hydroxide. Is that correct? Lutetium hydroxide will have least basic nature because across the period it is decreasing. This is the wrong statement. Lanthanum hydroxide is more basic. This part will be more basic. The last part, right part, will be less basic. So that's why this is the wrong statement. Okay. Next, lanthanum is actually an element of transition series rather than lanthanoid. Yes. Now, actually, when you take lanthanum, it is belonging to the transition series. But since its property is matching with the lanthanides, we have taken lanthanum element. I'll show you this one. Maybe you'll get a clarity. This is actinum. Yes, look here we have this lanthanum element. What do we call, which element do we call as F block element? We say the electron should be in F orbital. If you see lanthanum, it doesn't have electron in F orbital. It has electron in S and it has electron in D. So if you take the definition according to electronic configuration, this doesn't come under F block elements. But since lanthanum property is matching with the F block elements, we have counted that under F block element. Okay. So that is the reason. Remember that. It is according to electronic configuration, you can say it is from D block. Where is that question? Yes. Next. This is also correct statement. In lanthanide series, the ionic radius of lutetium is smallest. Correct. From left to right, the ionic radii is decreasing. That is what lanthanide contraction is. From left to right, it is decreasing from lanthanum to lutetium. So obviously, lutetium ion should have small radii. This is also correct. Next. Atomic radius of zirconium and hafnium are same because of lanthanide contraction. Just now we discussed, alva. Zirconium is 4D series, hafnium is 5D. Just now we discussed, alva. 4D and 5D elements will have similar radii. This is the reason. Lanthanide contraction is the reason. So this is also correct. Option A is wrong. Now, I want correct answer for this. Decreasing order of ionic character. Decreasing order of ionic character. Think and tell me. Think and tell me. We have discussed Fazan's rule. Fazan's rule we have discussed, right? So, this ionic character, it has something to do with the basic nature.
C.
C. Okay. So this is how you have across the period. Let's say rather than writing like this, it is better for you to write like this.
Option A, ma'am.
Option A, very good, very good.
Option
Look,
C.
this is how we have across the series, okay? These are the ionic sizes. Now, as covalent character increases, we know ionic character decreases. Ionic character decreases. Now, how do you say covalent character is increasing or decreasing? You say based on the size of the ion. As size of ion decreases, what happens to covalent character? Covalent character increases. Covalent character increases. Which ion has smaller size? Lutetium. That
Lithium.
means you will see high covalent character in lutetium ion. High covalent character means ionic character should be?
Less.
Ionic character should be?
Less.
Less or more? Less, right? So ionic character less, covalent character more. Okay. So that means, do we have that order? Yes. Samarium, gadolinium, terbium, lutetium. Yes. Very good. Very good. Yeah. Okay, students, we don't have enough time. Now, I'll be discussing 2 to 3 few more questions of this chapter, the same if block elements tomorrow also. Then we shall start with alcohol phenol ether. Alcohol phenol ether. Okay. So, for those whom this chapter alcohol phenol ether is completed, go through that and come. Okay. And you have to find out one more thing. I'm giving you one thing. As ionic character decreases, basic nature also decreases. Why is this? Why is this? Think and find out. If you don't get this, I'll explain you, but try to think why this is the this thing. Ionic character decreases, basic nature also decreases. Okay, fine. We'll wind up our session over here. Thank you.